The example of gasoline direct injection with DI Motronic shows you how. 4 functional modules are the focal point. First, cylinder charge control. This ensures that the correct amount of air is supplied. Second, precise injection directly into the combustion chamber. Here, the injected fuel, together with the air that's been sucked in, form a combustible mixture. Third, the ignition. For high efficiency, the right timing is crucial. And fourth, the exhaust treatment system. The Lambda closed-loop control ensures maximum effectiveness of the catalyzer. Nothing earth-shattering, you might think, but bursting with innovations just the same. Creating a perfectly functioning system from many components, a system that reacts ideally to any situation, is an art, because each situation demands an ingenious strategy from the engine management. Let's take the example of starting a cold engine in low outside temperatures. Here especially, the air mass has to be controlled with the utmost precision. This is why Bosch has developed the first plastic throttle device. This saves a great deal of weight and improves function, as the valve can be adjusted with superb precision. But that's just one example among many. Now we'll take a ride on a country road, completely relaxed in the lower speed range. Maximum precision is also required in everyday situations such as this. The high-pressure fuel pump delivers the fuel and brings it to an injection pressure of up to 200 bar. The special thing about this pump is, it doesn't matter whereabouts in the world you are, it's suitable for all qualities of gasoline all over the world and lasts the entire life of the automobile. But sometimes you need more than low torques. At high speeds, function has to be exact. For example, when overtaking on the freeway. With its homogeneous mixture, the DI Motronic provides the driver with the correct torque. Now it's a question of the right timing. The higher the engine speed, the faster all the injection processes have to be measured, calculated, triggered, and executed. Evaluating sensor data on the required torque, air mass, temperatures, and pressures. Controlling the air charge by means of the throttle device. Calculating the fuel mass and timing for injection. Actuating the injector. Calculating the moment of ignition, producing ignition sparks. Measuring the exhaust gas composition and regulating the mixture formation via the Lambda closed-loop control. And all this for every single injection, always adapted precisely to the momentary operating conditions. These days, the engine management system must provide not only reliability and dynamics, but also exhaust gas treatment for the benefit of our environment. In stop-and-go urban traffic, the operating conditions are constantly changing. The required torque changes in fractions of a second. In order to keep harmful emissions to a minimum at the same time, the Lambda sensor must precisely analyze the flow of exhaust gas. Oops, sorry. We continue to further develop the Lambda sensor to make it ever smaller and lighter, so that it can be installed closer to the engine. The sensor will thus be ready for operation more rapidly when the engine is started. The DI Motronic receives information from the Lambda sensor about the concentration of oxygen in the exhaust gas, and this in millisecond intervals. This enables the Lambda control of the DI Motronic to react immediately, keeping well within even the most stringent emissions limits. Regardless of whether we're talking about cylinder charge control, injection, ignition, or exhaust treatment, our focus is on customer service and customer orientation for the